Hello everyone, today we're going to look at usaco-training Hamming codes. So in this problem we're given three integers, n, b, and d, and then we're supposed to find n code words or integers which each have a length of b, or a length of b in like binary form, and then each of those code words or integers have to have at least a Hamming distance of d from each of the other code words. So Hamming distance is basically the difference between the bits. So for example, you can see that over here you have this number in binary form and this number in binary form. And as you can see, this digit and this digit is different. This digit and this digit is different. And these three and these three are also different. So then the Hamming distance would be 5. Which is the number of like digits that are not the same. Okay, and then we're basically supposed to just print the n code words sorted and like 10 per line. And then we should like get it like lexicographically earlier form. Okay, so let's go over here. So notice that the n is constrained by n is constrained by 64, b is 8, and d is 7. Alright, so let me just write this out. So we have 16, 7, and 3. The answer is 0, 7, 25, 30, 42, 45, 51, 52, 75, 76, 82, 85, 97, 102, 127. Okay, so basically, one thing is that because we always want the lexicographically earlier, like n code words, then we know that basically we want to start from the so we want to start from like from smaller numbers to bigger numbers. So what we can do is that we can start from 0. Let me just use blue because that's the smallest binary number, which in binary form, let's just say here we have b equals 7, so then this would be 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7. And then you know that our upper bound of this to search is basically 2 to the 7th power, which is basically 7 ones instead. And we know that basically since we're given b equals to 7, we know that basically like for each of our like individual digits over here, it can be like 0 or 1, which then we would have 2 to the 7 combinations. Okay, so what we can do is that we can first have like an array which we keep track of our answer, which originally it would be equal to nothing. Okay. So now when we loop through each of these, let's call this x, so as x. We have to check that basically the Hamming distance between the previous ones that are calculated and our answer has to be at least greater or equal to d, so d. So for example, we first check for x equals 0. Since there's nothing in our answer yet, we can just insert it to our answer. So then after this, our answer would be equal to, it would have 0 in it. Okay, so now let's just say we have x equals 1. Right now, currently our answer has one element, which is 0. So now we check the Hamming distance between these two numbers. So we know that the binary form of 0 is 0, 0, 1 is 0, 1. And then our Hamming distance would be 1 because there's only one digit that's different. So then when you look at over here, our Hamming distance must be greater or equal to 3, which wouldn't work. So then we wouldn't insert 1. So after this process, the answer would still be equal to 1. I mean 0, like one element with 0. So then let's look at our answer. So the next element we have is 7. So let's just test this out. So we have x equals 7. Right now we're just going to assume that answer right now only has 0 in it. So now we need to check the Hamming distance between 7 and 0. So so we know that 0 is equal to 0, 0, 0. We know that 7 is basically equal to 4 plus 2 plus 1, which then this would be equal to 1, 1, 1. And as you can see, the Hamming distance between 0, 0, 0 and 1, 1, 1 is 3 because each of these digits are different. And this would satisfy like our property over here where we have to have our Hamming distance at least 3. So then basically, because this would be true, then after this you would actually insert 7. So now basically for each loop, since we only want to find the first n code words, after we reach when our answer is the size of n, then we don't need to like keep calculating, so we can like break out of that loop. So now we just need to count basically we need to count we need to have like a function to count the Hamming distance between two numbers. So for example, let's call this Hamming. So we should take in like an integer a and an integer b. When C++, we can actually use a bit set to make this faster. So you know that the maximum bit size or the maximum bits in the number can be 8, since as you can see that's what we're constrained over here. So we can first initialize a bit set. It should be of size 8. Let's call this b. And let's initialize this by a XOR b. So what I mean by this is that, for example, if you take 0, 0, 0 and 0, 0, 1, the XOR would be basically the digits that are not common. So basically, you count each of these individually. So for example, if these two digits, or you count this and this, this and this, and this and this. So basically, if these two, or if each comparison, if these two digits are equal, then your XOR would be 0. Otherwise, it would be 1. And I'll actually just write this out. So here's our XOR table. So you have 0, 1, 0, 1. Okay, so for 0, 0, you know that these are the same. So then there'll be 0. And then for 0, 1, it will be 1, 1, 0. So this is basically what we want, like our XOR. Why? Because for example, because after XOR, we just need to count number of bits that are ones, because it just takes the elements that are different. So since we can actually just use the bit set to our advantage, we just need to return basically our bit set dot count, and this basically just counts the number of ones that are in A XOR B. Okay. So then, so one more thing. Whoops. So our overall complexity would be basically 2 to the b times n. So this would be, and this would run in time, since 2 to the 8th is like pretty small. So this should run really fast. Okay, so here, this problem is called Hamming codes. Okay, so let's include just bits, or let's actually just include fstream, and we also need to include bit set. Okay, so we have three variables, N, B, and D. So let's declare them. Okay, so let's read them. So include, I forgot the L, and I misspelled that. So let's use fstream. So we can do ifstream fn, and we're reading from hamming.in, and we're writing to hamming.out. Yeah, so I forgot to include the standard using namespace std. Okay, so now we need to read N, B, and D. So let's have our answer representing the number ones we have right now. So let's actually use a vector. So I just need to include that. So let's call this vector of int. Let's call this our answer. Okay, so we need to basically loop through each of our numbers. So it can be from 1, and it can be up to 2 to the power of b. Okay, so let's call this because we need to make sure that this number and all the elements currently in the answer each have a Hamming distance greater or equal to d. So what we can do is that let's call this our flag. It should be 1 by default. So for each element in our answer, we need to basically so we need to check if the Hamming distance of x and I is greater than or equal to a. So let's actually make our function. So in Hamming, so we should take in a and b. So let's call this our bit set. We have our size a. Let's call this c. So a XOR b, and then we just need to return c.count. And as you can see, it returns the number of bits which are set, which is the number of ones. Okay. So now basically if the Hamming distance between x and I is less than d, then you know that this won't work because one of the distances are less than d. So then you can just break since you don't need to calculate more. So now you can basically, if there's a flag, then you can insert it. So answer.pushback I. And now basically once we inserted it, we have to check if the number of elements in answer is equal to n, because if it is, then we're finished calculating. So basically if answer.size is equal to n, then we're done, so we can break out of this loop. So now the only thing is that we have to print 10 per line. So let's actually print this. So we have to print each element. So this should actually be n. All right. So what we can do is that basically the first n numbers are 0 to 9. So once you reach 9, or actually in the beginning of 10, you have to put a new line. So basically you can do if I and I mod 10 is equal to 0. And because I don't want to print a new line in the beginning, so we can basically skip this for I equal to 0. So we can actually just do if I not equal to 0. Then you have to print a new line. So now we have to print a of I, or answer. All right. oops, it's actually F out, so, or it's actually answer of I. Alright. So let me try this. So this is Hamming.n. What we're given the sample is 16, 7, and 3. So let's run this. Okay, so we got Hamming out. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and those, and that looks like, that does not look like what we want. Okay. So as you can see, we're looping through each of our answers. Oh, we should actually set this flag to false because we know that this won't work. Whoops, my bad. Okay. Okay, 0, 7, and this looks like it's right. Okay, so here we go. Problem, and let me select the files. Okay, this is Hamming codes. Oh yeah, so I forgot to put my login ID, so, or the like front matter. So, okay, here, let me just select it. Okay, so it looks like I did not format my output correctly. Okay, so we're not supposed to end it in like a new line, and okay. Oh, so my output did not end in the new line, and I have like an extra space here. So okay, so let's actually like make this more like efficient. Okay, so let's have a variable called like how much we printed. It should be 0 by default. So we know that we have to first print answer of I. And if basically if oh yeah, so my bad. So we have to first increment our printed since we just printed another variable. So printed, you just increment it. Let's actually make that. Alright. So now if printed is equal to 10, then you can like reset the counter, so printer would be equal to 0. And then over here you would print a new line. If not, then you would just print a space. Alright, so after this you should just print. Basically our last one is if it's equal to 10. So basically if not printed, then or basically if we printed some stuff, then you can see out an end line. Hope this like formats correctly. Whoa, okay, so I'm not printing any spaces. If printed is equal to 10, then you reset it. Oh, I'm putting C out instead of F out, so my bad. Okay, so right now I am ending in a new line, but it looks like I'm actually printing an extra space, so this should actually occur when or I is equal to n minus 1. Okay, so basically if it's the last element, then you also print. So now we can actually take that out. Alright, so I think that is, wait, so I think that's correct. I am ending in a new line, so let me try submitting again. Okay, so okay, so it looks like that is right. So if you have any questions, feel free to leave them in the comment section below. Bye.